All right, so the next lesson on chapter 1 is graphing proportional relationships. So in the past, just recently, we talked about what is proportional, what's not proportional. We found out, if we're looking at, for example, all the information's in tables, we found out the unit rate and compared them. Today, we don't have to do any of that. Today what we're going to do is we're going to be able to take a look at a graph, all right? And I'm going to give you the skills that you need to be able to just look at it and find out whether or not it shows a proportional relationship or not. So here's what we're going to do. Before we get to that, we do have a number of different vocab words. So here we go. The first vocab word or phrase is coordinate plane. Everyone? So here's what your book says. A coordinate plane is a plane in which a horizontal number line and vertical number line intersects at their 0 points. It's also called a coordinate grid. Okay. So the little homework that I give you on test days, where you're just graphing or plotting points off of ordered pairs, and you connect the dots to make a picture. Okay, that's what we're talking about. The whole thing, the whole paper the grid that you're plotting the points on, that is considered the coordinate plane. So for the sake of notes, just go over to your little box and go ahead and put like a little plus sign with arrows. What that basically is a little mini x-axis and y-axis, just as a little reminder. Okay, the whole thing would be the coordinate plane. Okay, now the next word. All right, the next word is quadrants. Everyone? Okay, so here's what quadrants are. It says one of the 4 regions into which the 2 perpendicular number lines of the coordinate plane separate the plane. All right. So, and I don't know if we've talked about this before, but here's what I want you to write down in your little box. Go ahead and write down the exact same thing, just a little x and y axis, making like what appears to be the coordinate plane. Now what it's saying is that this little like plus sign, the x and y axis, they break up the plane, the grid, into 4 sections. All right, and these 4 sections are called quadrants, like this says. So here's what we're going to do. We're going to go ahead and number them, using this to number it. In the top right-hand section up here, we're going to go ahead and write quadrant 1. Here's how you write it, with a Roman numeral, quadrant 1. Okay, like a capital I. Okay, actually top left, so going left, the top left, that is considered quadrant 2. So it's a Roman numeral 2, all right, like 2 capital I's next to each other. Okay, right below that, the bottom left is considered quadrant 3. Quadrant 3. And then the bottom right is quadrant 4. So like a capital I and a capital V right next to it. Quadrant 4. Those are the 4 quadrants. Okay, we'll talk about this in a bit, but today's lesson actually only refers to quadrant 1. That's all we're dealing with. Okay, so here we go. The next word, all right, is a word that you've heard before, and I've even said it in this lesson already. X-axis. Everyone? Okay, so the vocabulary in your book says it is the horizontal number line in a coordinate plane. The horizontal number line in a coordinate plane. So right in your little box off to the right, again, go ahead and put your little coordinate plane there with the little x and y axis. Okay, and here's what I want you to do. Take the horizontal line right here and take your pencil. I know I have a red pen, but you take your pencil, make it a little thicker, like it's bolded. Okay, because that is the horizontal number line. That is the x-axis. Now we have the x-axis, and our next word is y-axis. Everyone? Okay, the y-axis is the vertical number line in a coordinate plane. The vertical number line in a coordinate plane. Okay, so in your little box, go ahead and draw your little coordinate plane again. And then again, this time though, let's go ahead and scribble in the vertical one. So there we go. The vertical, that is your y-axis. Okay, so there are a lot of words in this lesson. So we have 4 down, 4 more to go. All right, so here we go. All right, the fifth vocab word is origin. Everyone? Okay, here's what the origin is. It's the point at which the x-axis and the y-axis intersect in a coordinate plane. So you could say that the origin is at, and then there's an ordered pair in parentheses, 0, 0. If you don't remember that, we'll talk more about that in a bit. Okay, here's what I want you to draw in your little box off to the right. Go ahead and again draw your little coordinate plane, your little x and y axis. I tried my best to put that dot there, but that dot represents the center. And the center of where those two number lines cross, that is called the origin. Okay, when you graph it, you graph or plot points on a coordinate grid, you always start at the origin, and then you move according to your ordered pair, which we'll talk about here in a second. Okay, I want to take this time really quickly. We're going to use the word origin in our lesson. All right, and the origin, here's what's going to happen is all of our problems are going to deal with more positive numbers. And if you're talking about the x and y axis both being positive, most of today is going to deal with quadrant 1 up here. All right, this top right-hand corner. Okay, so here's what I want to talk about though is if this is all they're going to show you in a problem on a graph, okay, the origin is right where that L shape, right in that corner right there. Okay, because it's not going to show you how the y and the x-axis keep going. It'll just be blocked off right there, but that is considered the origin, that part where both of those arrows come together. Okay, that will be considered the origin. All right, with that said, here we go. 3 more. Okay, the next one is called ordered pair, everyone. Okay, so ordered pair, this is a pair of numbers used to locate a point on the coordinate plane. Okay, an ordered pair is written in the form, and then in parentheses, it's always the x-coordinate first, the comma, and the y-coordinate. Okay, so this is how it will look. It'll always be in parentheses, x, comma, y. And of course, the x will be a number or an integer, and y will be an integer. But it's in that form right there. That's what an ordered pair looks like. So talking about ordered pair, okay, we're going to go ahead and talk about each of these separately. The first one is x-coordinate. Everyone? Okay, so the x-coordinate is the first number of an ordered pair. It corresponds to a number on the x-axis, all right, the x number line. So in your little box, go ahead and write another ordered pair, x and y, but of course you might want to just kind of underline the x or make it more bold because that's the x-coordinate. That one number that is right there will be the x-coordinate. And of course, you probably know where this is going. If we have an x-coordinate, the next phrase is y-coordinate. Everyone? Okay, so a y-coordinate, this is the second number of an ordered pair. It corresponds to a number on the y-axis. All right, so go ahead and write down your ordered pair again, x, comma, y, in parentheses. Okay, and then go ahead and just kind of underline the y. That's your y-coordinate. It will be that second one right after the comma. Okay, so those are our notes. All right, our vocab notes. So go ahead and grab your book and flip your book over to page 48. Page 48. Okay, on page 48, all right, looking at the guided practice. Here's what we're going to do. All right, let's go ahead. Let's start at number 2. Okay, I know the copy didn't come out very good, but I know that your book page looks a lot better. All right, so here we go. Number 2 says the number of books 2 stores sell after 1, 2, and 3 days is shown. Which book sale represents a proportional relationship between the time and the books? Explain. All right. So, here's the thing. First of all, I want to explain this. Just where you know what I was talking about earlier during our vocabulary, take a look. This is the y-axis. Now, I'm just going to show you, you don't have to do this, but this y-axis keeps going that way. Here's the x-axis. It keeps going this way. And if you kind of use your imagination, you can see the grid is not in these quadrants, quadrant 2, 3, or 4, but this is quadrant 1 up here. It's because that's where all the positive numbers are, positive integers. So, if you take a look, they actually talk about this, or they give you this on the x-axis is the x-axis are the units based off of days. These are the number of days: 1 day, 2 days, 3 days, 4 days, and so forth. All right, that's of course the time. Okay, and the y-axis, the units are books. All right, so for example, 3 books, 6 books, and 9 books. All right, so the graph, of course, represents what it told us up here that we just read. All right, so here we go. The most important part of this lesson is this right here. And we'll call this step 1, even though it's not quite a step. All right, and I guess it is. All right, but you need to know this to be able to do the first step. All right, so there are 2 conditions, all right, 2 things on a graph, 2 conditions on a graph which shows.
Gabriel Mendoza, please come to the Rayburn office. Gabriel Mendoza, please come to the Rayburn office.
2 conditions on a graph which shows a proportional relationship. All right? So you can kind of think of this as a test. And for a line to be proportional, or to show a proportional relationships between, for example, like this, the days and the books that are sold, okay, these have to be the 2 things. All right? First, to be this line or this line here to be proportional, the first thing it has to be is it has to be a straight line. It has to be a straight line. No bend in it, no curve. It needs to be a straight line. And the second condition is this. Besides a straight line, it has to pass through the origin. Now you might say, well, Mr. Wilkins, what do you mean through? The origin stopped. Did both of these stop? Well, yeah, that's true. If this is a little more complicated problem, these could pass right through the origin, right through that point right there. Okay, in this case though, right, because we're only dealing with quadrant 1, it's just stopping at the origin, which is still the same. So if we're taking a look, this condition right here, yeah, they both actually pass through the origin or stop at the origin. Okay, however, there's only one that's a straight line, and obviously this one's crooked. This isn't straight. So this is not a proportional relationship. This is. So when I reread this, it says, which book sale represents a proportional relationship between time and books? This is step 2. We're going to answer our question here. Okay? So step 2, we're going to go ahead and list it. It's the Book Palace. The Book Palace. But don't forget, it does say explain, and we need to make sure we remember. We need to give a reason why that's the case. So we use the word because. And now this part is very easy. All right? On your homework tonight, your explanation is a very clear-cut explanation. All right? And here it is. I'm just going to back it up with that right there. The Book Palace, because it is it being the graph, or the line that's graphed, it is a straight line, here's number 1, which passes through the origin. Oops. There you go. All right, that's problem number 2. Okay, so here's what I would like you to try, is to go ahead and go to your homework. And what I want you to try out is flip to page 49. And I want you to try out problem 3. Problem 3. All right, I'll give you 30 seconds. Go. Okay, go ahead and turn to your neighbor. Another 30 seconds. Here's what I would like you to do, and this is all you need to do, is go ahead and just give your written answer with your explanation. But please make sure your partner, when they explain it, they have their actual explanation of how they got their answer. Okay, so 30 seconds, turn to your neighbor and share. Go.
Gabriel Mendoza, please come to the Rayburn office. Gabriel Mendoza, please come to the Rayburn office.
All right, here we go. It says number 3. It says the height of 2 plants is recorded after 1, 2, and 3 weeks, as shown in the graph at the right. Which plant growth represents a proportional relationship between time and height? Explain. All right, so here we go. I'm taking a look, and remember, I need to think of my 2 conditions. These lines have to go through the origin, which in this case is touching the origin. Both of them are, but remember the second condition, it has to be a straight line. Ladies and gentlemen, plant B is our answer. So here we go. Which plant shows a proportional relationship when it comes to its growth? So it is plant B, and then don't forget, right, this is all step 2, because, and here we go, make sure you have both conditions in here. It is a straight line which passes through the origin. Okay, so with that said, now what we're going to do is we're going to pretty much do I don't want to say the exact same thing, but something very similar, but there's a little actual graphing involved. So what I want you to do, let's go ahead and take a look at page 48 again. All right, and let's take a look at problem number 1 this time, number 1. Okay, so number 1 says the cost of a 3D movie, or cost of 3D movie tickets, is $12 for 1 ticket, $24 for 2 tickets, and $36 for 3 tickets. It says determine whether the cost is proportional to the number of tickets by graphing on the coordinate plane. Explain your reason. All right, so here's what we're going to do for this particular problem is step 1. Okay, step 1, we're going to take one little step at the very beginning, which is a pretty important step for some of us, and that is take a look at what the x and the y axis represent. Okay, so the x-axis it shows are the amount of tickets. Of course, in this case, it's the number of tickets that would be bought, for example. And then the y-axis is the cost. So how much each of those cost. All right, so here we go. Step 2 is I'm going to go ahead and graph these. So I'm going to take a look. And this first one here, $12 for 1 ticket. Okay? If it helps you, you can put $12 over one ticket as a rate. Okay? But you don't have to, but you can if it helps you. And then I'm going to go ahead and graph that exact one on here. So $12 for one ticket. So let me see. It doesn't matter which way we go. I'm going to start with the ticket. Tickets are down here on the x-axis. So I go over to the 1, and one ticket it says is $12. So I'm going to go up with the 12 on the y-axis, and I'm going to plot my point. Now I'm going to go ahead and continue with step 2. Okay, we have other numbers that they gave us. So we have $24 for 2 tickets. So again, I'm going to start with tickets, go over to 2, and then $24. So the cost, I'm going to go up even with 24. Plot my point there on the grid, on the coordinate grid. And the last one is $36 for 3 tickets. So I go over to the 3 tickets, go up to $36, plot my point. Now, step 3 is I want to draw a line. Now, guys, what I would recommend when you draw your line is use some kind of straight edge. It doesn't matter what it is. I can use a tongue depressor, popsicle stick here. You can use the edge of a folder, whatever works for you. And I'm going to go ahead, oops, try not to let it move, and draw your line. Okay, now what we have in front of us is we pretty much have a shorter version of problem number 2 here. So I need to go ahead and do step 4, and that is answer my question. And remember, determine whether the cost is proportional. It's not saying it is or it's not. It's asking us to decide. And see if it's proportional. Okay, the cost is proportional to the number of tickets. Okay, so here we go. Is it proportional? Well, we take a look at our 2 conditions, right? Is it a straight line? Yes. Does it pass through the origin? Well, yeah. It hits at 0 right there on the x and y axis. So I would say it is proportional. It is proportional, and of course the explanation, because, here we go, it is a straight line which passes through the origin. All right. So I'm about to give you one, just a little reminder, right? Before we do anything, check your x and y axis, because it might throw your whole graphing off if you don't. Okay? And then when you graph, of course, be very careful. All right? If you want to write your rate here, you can. In this case, $24 for 2 tickets. Okay? But it's totally up to you. If you want to just graph it off of here, just make sure that you're using the units on your x and y axis. All right? When you graph, use the straight edge to do your line as well. Okay? You don't want to make an accidental mistake. Okay. Here's the one I'm going to have you guys try. All right, and I'm going to have you try problem on your homework. Problem number 1 on your homework. So flip back over to page 49 and try out problem number 1. Okay, problem number 1. All right, go. Okay, 30 seconds. Go ahead and turn to your neighbor. When you share, I want you to share your answer, but also with your explanation, of course. But also, I want you to share your graph. Make sure that you guys graphed everything correctly. All right, 30 seconds. Go. Okay, so this is kind of interesting, right? And you probably have realized that this isn't even a word problem. Actually, probably makes it a little easier for you. Okay, it's almost set up in an X and a Y. I mean, if you wanted to, right, you could say the weeks are the Y. I'm sorry, the weeks are the X-axis. The account balance is the Y-axis. Okay, so if you were to put it, you'd say 1 and 125 as your ordered pair. Okay, you didn't have to do that. It didn't say to do that, but you could have. All right, so which leads me to this. What I just said, X-axis is the weeks, Y-axis is the balance, the money. Okay, so after week 1, it looks like, because it's talking about a savings account, week 1, the account balance is $125, and it's in dollars, so $125. So after week 1 is $125. So go week 1 up to $125. And then comes week 2. So week 2 is $150. So after week, here's my week 2 up to $150. And week 3 is here. It's $175. All right. So grab a straight edge, draw a line. All right, so I took a look at that and I test it. And I say, okay, is it showing a proportional relationship? Well, first, it is a straight line, that's good. However, it doesn't go through the origin. Now, I have had people in the past say, well, Mr. Wilkins, what if I take this and connect it with the origin like that? Well, if you do it like that, but then you graph the rest, now it goes to the origin, but it's not a straight line. So either way, it's not proportional. So it says, of course, determine whether or not it's proportional. Explain your reason. You would set your reasoning. It says, you could say it is not proportional, or you can use the vocabulary we've talked about. It is non-proportional. Because comes the explanation, is non-proportional because, and if I just use the red line, I would put it does not pass through the origin. Now again, if you used the blue line, you would have said it is non-proportional because it is not a straight line. Now it all depends how you graphed it. Okay, but if you're using a straight edge like I'm asking, more than likely your graph looked like the red one. All right? So fairly easy, just a couple of different type of problems that you're going to see today on graphing proportional relationships. All right? There you go.